Hello. Hello.
Yes, ma'am.
Okay, very good afternoon for you all.
Good afternoon, ma'am.
Good afternoon.
Good afternoon, ma'am.
All are there.
Good afternoon, ma'am.
Good afternoon. Shall we start the session or we'll wait for another few minutes?
Start, ma'am.
Okay. Take the first problem. Have you taken the problem? Have you taken the problem? Had you all taken the problem? Rakshita Nayak, Rohini, You all. Hello. Hello.
Yes, ma'am.
Yes, ma'am.
You all are there.
Ma'am.
Have you taken the problem?
Yes, ma'am.
Okay. So let us solve this problem. So calculate the dynamic viscosity of oil which is used for lubricating between a square plate of size 0.8 by 0.8 meter.
Side is not visible, ma'am.
It is not visible.
No, ma'am.
No, ma'am.
Let me check.
No, ma'am.
Now is it visible?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, it is visible.
So you need to calculate the dynamic viscosity of oil. We don't know which kind of a oil it is. Okay. So that oil is used for lubrication between a square plate. Okay. So the size of the plate is 0.8 meter by 0.8 meter and an inclined plane with an angle of inclination 30 degree. The weight of the square plate is 300 Newton and it slides down the inclined plane with a uniform velocity of 0.3 meter per second. The thickness of oil film is 1.5 mm. So take this diagram. So this is the plate, square plate, which is having a size 0.8 by 0.8 meter. So in between plate and the fixed surface, an oil is placed. The thickness of oil is 1.5 mm and the plate moves with a velocity 0.3 meter per second and the weight of the plate is 300 Newton. And the angle of inclination is 30 degree. Have you all taken the diagram?
Yes, ma'am.
What about others? Amogh Torgal, Megha, Praveen Sungar.
Yes, ma'am.
Have you all taken the diagram? Okay. So now
Yes,
write
ma'am.
all the given things. So calculate the dynamic viscosity. So dynamic viscosity is indicated by which symbol? Dynamic viscosity is indicated mu. Very good.
Mu.
So it is mu. Okay, so that you need to identify. Next, a square plate is placed there. So what is the shape of the plate? What is the shape of the plate?
Square.
Square plate.
Square.
Okay, then what is the area of the plate now?
Breadth into height. Depth
How
into
much
height.
it will be?
0.8 meter into 0.8 meter.
How much it will be? Area of the plate. 8 8 how much?
0.8 into 0.8.
0.64 meter square, ma'am.
Okay, what is the unit for area? It
Meter
is
square.
meter square. Okay. So now, what is the other thing they have given here? Angle of inclination. Angle of inclination is indicated as symbol theta. So I am going to take theta as how much? It is 30 degree.
That's correct.
Okay. Sorry. Next, what is the weight of the plate? Weight of the plate acting
300
in
Newton.
vertical direction.
300
W is equal to
300.
okay.
300.
Weight of the plate is 300 Newton. Okay. Apart from that, what are the other details they have given? They have given the velocity. Velocity, I am going to indicate it as a small u, which is equal to, actually it is a small u, not capital U. It's 0.3 meter per second. Okay, next. What is the thickness of oil film? So this is nothing but the oil film. What is the thickness of that?
0.5 mm.
0.5 mm, ma'am.
So T is equal to, it is 1.5 mm. So T can be also written as what? It is also equal to dy. Okay. Thickness is nothing but it is dy. Is it okay? So now, in which equation the term mu is going to occur? Tell me. In which equation the term mu is going to come? That is more important here.
Mu
In which
equals to into du by dy.
mu equals to
T into du by dy.
tau is equal to mu into
Mu into du by dy.
du by dy. Okay. So what they have asked you to calculate, to identify, you need to identify mu here. So therefore, this equation can be also written as mu is equal to tau divided by, it is du by dy. Okay. So now, what do you mean by tau? What is tau here?
Shear stress, ma'am.
Okay.
Shear stress, ma'am.
Okay. So shear stress can be written as what? What is the definition of shear stress?
Force by area, ma'am. Resistance force by area, ma'am.
Okay, very good. So it is force divided by area. Okay. Now, first you need to identify tau. Okay. So once you identify tau, the value of a tau is equated here. Next, you know the initial velocity. Initial velocity minus final velocity. There is no final velocity. Therefore, du can be written as it is initial velocity minus final velocity. Final velocity is equal to 0. So therefore, what will be the value of a du here? What is the initial velocity, my dear students? What is the value of a u here?
0.3.
0.3 meter per second.
It is 0.3 meter per second because there is no final velocity. So you know du and you know dy. So once you equate these values, you will come to know what is the value of a mu. Understood up till here?
Yes, ma'am.
Understood up till here?
Yes, ma'am.
Okay. So now in this particular diagram, so the weight, it is acting in vertical downward direction. Okay. It is acting in vertical downward direction. So when you are going to resolve this force by taking in the direction of the velocity. What I am saying is the weight is acting in vertical downward direction. So this weight I am going to resolve it in horizontal direction towards the direction of the velocity. If W is equal to 300 Newton, when you are going to take in the horizontal direction, so the force will be equal to the force exerted, that is the component of the weight along the plane will be equal to, so component of the weight along the plane is equal to, it is W cos 30. Okay, so in this particular problem, the weight is acting in vertically downward direction, but the movement of plate is in the other direction. So that's why I am going to resolve it by taking the weight towards the direction of the velocity, towards the movement of the plate. So when you are going to resolve it, the term W will become W cos 30 degree, because the angle of inclination is 30 degree. So equate the value of a W. W is equal to how much? 300 cos 30 degree will be equal to how much? 300 cos 30 degree will be equal to how much?
259.80.
Pardon?
259.80.
259.80
Newton.
Newton it is. Okay. So now this is nothing but the force exerted, that is 359.80 Newton. So this is the force. Okay. So now equate the value of a force and equate the value of a area and tell me the value of a tau. Tau is equal to how much? Tau is equal to how much?
405.93.
405.93. All of you got the same answer? All of you got the same answer?
Yes, ma'am.
Okay, what is the unit for tau? Force, how we are going to calculate? Force is calculated in terms of a Newton. Area is calculated in terms of a meter square.
Newton
Okay.
per meter.
So this is the value of a tau. Hope all of you have got the same answer. Only few of them are replying. What about others? Sushmita?
Yes, ma'am. Got same answer.
All of you got the same answer?
Yes, ma'am.
Okay. What is the next step now? You have identified the value of a tau. Equate the value of a du by dy and tell me the value of a mu. Tell me the value of a mu now. What is the value for mu?
Ma'am,
Yes.
tau value is 1623.
Mu value I'm asking. Dynamic viscosity mu. How much it is?
Ma'am,
And to the
81.18.
How much it is?
2029.65.
2029.665.
65.
What about others? What about others? All of you have got the same answer,
Yes, ma'am.
Yes.
but you have done a small mistake here. What is that mistake? 1.5
Tau value is 1000.
1.5 mm it is. Convert that into meter because we have identified each values in terms of a meter, right? So it will be 1.5 into 10 raised to. Now equate the value and tell me the answer. Fast. Hello, what is the answer?
Ma'am, 2.02965, ma'am.
2.029.
0.9.
Okay. Okay. What is the unit? Unit for dynamic viscosity?
Newton second per meter square, ma'am.
Newton second per meter square. Okay. If I ask you to calculate the mu in terms of a poise, in terms of a poise, how much it is? The value of a mu in terms of poise. Ask. In terms of poise,
20.29 points.
it is multiplied by 10, which is equal to 20.29 points. Okay. All of you have got the same answer. Is there any doubts?
No, ma'am.
ma'am.
Got answer.
Okay. Shall we move to the next problem?
Yes, ma'am.
Okay. So take the next problem. So the previous problem, mark it as a important. So it is very important from the exam point of view. So this is also very important problem. Many a times in the examination, they have asked problems on these concepts. It is a similar kind of a problem, but there it was a plate, but here it is a shaft. That is only one difference. Have you taken the problem?
Yes, ma'am.
Okay, mark it as a important. First, write the given things. What is given here? The dynamic viscosity of an oil used for lubricating between a shaft and a sleeve is 6 points. So dynamic viscosity is indicated with which symbol? Dynamic viscosity is indicated with which symbol?
Mu, ma'am.
Mu. So what is the value of mu they have given? Mu is equal to, it is equal to 6 points. So convert that into Newton second per meter square. How much it will be?
0.6, ma'am.
Okay, 6 divided by 10, which is equal to 0.6 Newton second per meter square. So now, what about the next thing? The shaft is of a diameter. So diameter of the shaft, how much it is? 0.4 meter. Number of rotation is taken as capital N, 190 revolutions per minute. Calculate the power lost. So you need to identify the power lost. Next, in the bearing for a sleeve length. Sleeve length is equal to how much? Is equal to 90 mm. Convert this into meter, that is 90 into 10 raised to minus 3. Meter. Okay. Next, the thickness of the oil film, that is small t equal to 1.5 mm. So this is equivalent to 1.5 into 10 raised to 3 mm. Mm or meters. Have you taken the given?
Yes, ma'am.
Yes, ma'am.
So now this is the diagram. This is the circular shaft. And these are the sleeves. The length of the sleeve is 90 mm. The length of the sleeve is 90 mm. So please draw the diagram. Diagrams are very important. This is the shaft. The diameter of the shaft is 0.4 meter and the length of the sleeve is 90 mm. The thickness of the oil film is equal to 1.5 mm. Have you taken the diagram?
Yes, ma'am.
What about others?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. So this is an example of a power generating plant. Okay. In case of a power generating plant, a shaft will be there. Okay. So this shaft is provided with the blades at the end. So these are the blades. Have you seen the hydropower plant? Hydropower plant nodiri. Hydropower plant nodiri. Hello.
Yes,
No,
ma'am.
ma'am.
Yes, ma'am.
Hydroelectric power plant where the power is generated. So once the water falls on this blade, so this particular blades will start rotating and this mechanism is placed on a shaft, a circular shaft. So in order to hold this shaft in a particular position, so sleeves are provided here. Okay, in order to keep this shaft in a exactly horizontal position, sleeves are provided. Okay, so this particular shaft will be rotating in the circular direction. In order to make it a free movement, this particular shafts are filled with the lubricating oil. Now you need to identify what is the torque generated and what is the shear stress. Okay, so this is an example of hydroelectric power plant. So now in this particular diagram, here you can see these are the two shafts. The length of the shaft is 90 mm. Therefore, you need to identify what is the torque generated for the 90 mm length. Okay, that you need to identify. Apart from that, you need to identify what is the shear stress. Okay, so now in order to solve this problem, we need to have the equation. So tau is equal to mu into du by dy. So this is the equation by which we can calculate the shear stress. But we don't know what is the value of a tau here. We know mu, we know what is the velocity. So how we are going to calculate the velocity? My dear students, in the previous problem, I said you that there are two types of equations are there by which we can calculate the velocity. Okay. If suppose they have given the distance traveled and the time taken, so d by t will give you the velocity. If they have given a number of revolutions and the diameter, which equation you are going to use to calculate the velocity? Which equation we are going to use to calculate the velocity?
By dn by 60, ma'am.
It is pi dn divided by 60.
60.
Okay, so pi dn divided by 60, where d is nothing but it is the diameter of the shaft, n is the number of rotations. Okay, now equate the value of a pi d n and tell me the value of a u. D is 0.4 multiplied by what is the value of a n? It is 190 whole divided by 60.
Ma'am, 3.97 meter per second, ma'am.
This is the tangential velocity of the shaft. Okay. So it is equal to how much?
3.97 meter per second, ma'am.
Meter per second. Okay. Was there any final velocity they have given? Was there any final velocity? Final velocity is there?
No, ma'am.
Okay.
No, ma'am.
Therefore, what will be du? Du is equal to initial velocity minus what is the final velocity?
0.
0.
0, ma'am.
Okay. What is the value of du9? Du is 3.97 meter per second. Okay. Simultaneously, what about dy? What is dy? What is the thickness they have given?
1.5.
So this is the thickness of the oil. It is 1.5 mm. So thickness, it can be also taken as a dy. Okay. So now equate the values. So this will be tau divided by, is it tau? Tau calculate ಮಾಡ್ತಾ ಇದೀವಾ ಅಥವಾ mu calculate ಮಾಡಕತ್ತೀವಿ ನಾವಿಲ್ಲಿ?
Tau, ma'am.
Tau. Okay. Now equate the value of a mu, du and dy and tell me the value of a tau. What is the value?
Minus 2.26 into 10 raised to minus
Minus.
4, ma'am.
No, ma'am. Tau, du by dy value, ma'am, 2646.66, ma'am.
Am I
Total-
about 1,508?
Tau value 1587.99 Newton per meter square, ma'am.
Hello?
Yes, ma'am.
What is the value of a
Yes,
tau you
ma'am.
have got? Value of a tau?
1587.99 Newton per meter square, ma'am.
97.99.
99.
Okay, what is the unit?
Newton per meter square.
Newton per meter square. Simultaneously calculate the value of a F. Because they have asked you to calculate the power lost. And this is the equation, general equation to calculate the power lost. That is 2 times I into N T whole divided by 60, where T is the torque. So for torque, T is, the equation for torque is force into capital D divided by, that is half the diameter. So these are the general equations. No derivations for this. So first you need to identify the torque. Identify the torque. So to identify torque, you need to calculate the force. So how are you going to calculate the force? By taking the equation tau is equal to force by
Area, ma'am.
area. Okay. So therefore force will be equal to tau into area. Okay. So this tau will be multiplied by area. What is the value of a tau we have obtained? It is
1500.
okay. What is the area of the shaft? It is pi d length of the shaft. These are the general equations. There is no derivation for this. Only thing you have to remember these equations. Now equate this value, that is 1597.99 multiplied by the value pi into, what is the value of a d? That is 0.4, and the length of the shaft is 90 into 10 raised to minus 3. Now tell me the answer for force. Force is equal to how much?
One 179.62 Newton, ma'am.
179.62
Newton.
Newton.
Ma'am, tau is equal to 87.99,
How much?
not 15. Tau is equal to 1587.99. You write that 159799. Tau, ma'am. Tau.
Tau is equal to how much?
1587.
87 it is. Is it 87 or 97?
87, ma'am.
Okay, then what is the value of a force?
Force is 179.62. 79.62.
160. So approximately it is 180 Newton. Now equate the value of a force here. 180 multiplied by, diameter is 0.4. 0.4 divided by 2 is 0.2. How much it will be?
36, ma'am.
36. 36. What is the unit for force? What is the unit
Newton,
for force?
ma'am.
Newton. Okay. Okay. Then what is the unit for diameter?
Meter, ma'am.
Okay. Then what is the unit for torque? It is Newton meter.
Meter.
Okay. Next, calculate the power lost. Calculate the power lost. Number of revolutions is how much? 190. T is 36. Whole divided by 60.
Ma'am, loss is 716.376.
7,
16.376.
713.6.
716.376. 16, ma'am, not 3.
716.37.
376.
Okay. So power we are going to measure in terms of a watt.
Watt.
Okay. This is how you need to calculate the things. So this is very important problem. So you need to remember these equations. Equation for torque, equation for power lost, and also equation to calculate the velocity. This one. Okay. Mark it as an important, very important problem. So take the assignment problem, solve it by yourself. Have you taken this? Take the assignment problem. The size of the plate is 0.9 by 0.9. Angle of inclination is 20 degree. Weight is 392.4. The velocity is 0.2. And the answer for this particular problem is 12.42. Please solve this problem. Okay, this is the assignment problem. Please note down the values. You all are there.
Yes, ma'am.
Yes, ma'am.
So solve it by yourself. The answer for this particular problem will be 12.42 points. Yes, students, is there any doubts in today's session? Is there any doubts
No,
in
ma'am.
today's session?
No, ma'am.
What about others? What about others?
No, ma'am.
Afreed, are you there? Ramu Vaddar, Rohini Patil, Shilpa Vadige,
Yes, ma'am.
Sushmita. You all are there?
Yes, ma'am.
Yes.
Is there any doubts? Is there any doubts in this?
No, ma'am.
Because
No,
these
ma'am.
problems
No,
are very important. I think you have taken this problem. Shall we wind up?
Yes, ma'am.
Yes, ma'am.
Okay, thank you.
Thank
We'll
you.
meet in the next session. Okay.
Okay, ma'am. Thank you.
Okay.